Okay, now we're going to look at something called the triangle inequality theorem. What this is called is not really all that important. The concept of this is that if I take any two sides of a triangle here, notice we have triangle TWX, and notice that we're summing two sides of that triangle. Okay, so we're going to add together, sum means add, any two sides of that triangle. And notice that those two sides, no matter what sides they are, always have to be greater than the third side. And it's just physically impossible, guys, to draw a triangle where you have two sides that are less than that third side. They'll never be able to reach that. Even if the two sides were flat, it would be equal for it to reach, much less being less than that. So, one of the things we're going to look at is just, hey, are these possible lengths for a triangle? And so we're going to take a look at this first one, 4, 5, and 7. So from this theorem, I know that if I add up any two sides, like 4 plus 5, those two sides there, which equal 9, it has to be greater than that third side 7. And that one definitely works. So we can check that one off. And it has to work for any combination. So if I take the 4 plus the 7, which is 11. Is 11 greater than now the third side being 5? Well, check. That one works also. And then the other two would be 5 plus 7, which is 12. And is 12 greater than 4? Obviously, yes. And so the answer for this one is a resounding yes. You might ask yourself, do I need to do all three of these, Mr. Frithmiller? And the answer is really no, you don't. The only one you really have to do is testing this one right here, which is the two smallest sides must always be greater than the third side. So you could probably change this. The sum of the two small sides, okay, or the two smallest sides, always has to be greater than the largest side. And as long as that one works, the other two should work out. And so let's take a look at this next one. Well, what are the two smallest sides here? Well, it's 5 and 2. So I'm going to add those two together, 5 plus 2, which is 7. And is 7 greater than that third side, 8? Well, in this case, the answer to that is no. 7 is not greater than 8. And so the answer to this one is no. That is not possible lengths of a triangle. Now let's look at the next one. Well, the two smallest sides here are 3 and 3. So 3 plus 3 is 6. Is 6 greater than 5? The answer is absolutely yes here. So in this case, yes, those are possible lengths of a triangle. And then the last one we'll do here is 4, 2, and 6. So the two smallest sides here are 4 and 2. So we'll add those two together, 6. Is 6 greater than 6? Well, the answer to that's no. 6 is equal to 6, not greater. So that one is a no also. Those cannot be the sides of a triangle. So one of the things that you can use this theorem for is to find out whether it's possible to make triangles with three sides or the three given sides. The other thing that you'll do with this is they're going to give you two lengths of a triangle, and we're going to state what is true about their third side. So we're given two sides of a triangle that are 15 and 23. So we want to know what is possible about the length of that third side. Well, there's two things we need to look at here. The first thing we need to look at is what happens if 15 and 23 are our two smallest sides? Okay, what happens if they're the two smallest sides up here? Well, then I know if I add those two sides together, 15 and 23, which is 38, that 38 has to be greater than that third side. And I'm just going to call this third side x. Okay, and then I'm going to reverse this because it just doesn't look quite right to me, not having the x first. And so I've got to flip the inequality. So I know that third side has to be less than 38. Now, is that the only thing I have to do? Well, no. The other thing we have to look at is what happens if 23 is the largest side? Well, if 23 is the largest side, it gets replaced for x here, so 23. And we know that the other two sides, 15 plus that third side x, have to add to be greater than that. So just doing a little bit of algebra here, we'll subtract 15 from both sides. So I know that third side has to be greater than 8. So what we're going to do, and what we'll do is we'll take these and we'll put these into a compound inequality. So x will go in the middle. We know it has to be less than 38. And we know it has to be greater than 8. Okay? And so there are the possible lengths for that third side. And that ought to make sense. If that third side was like 7, 7 plus 15 is 22. And 22, is it greater than 23? Well, no. So we know it's got to be 8 at the minimum. And we know it has to be less than 38 because, well, once again, that 15 plus 23 is 38, and it's got to be greater than the third side. So that third side can't be 39 or 40 or even 38.1 because it would then not be greater than, that third side would be less than, would not, those two sides would not be greater than that third side. Okay? So, Mr. Birthmark, do I have to go through all this stuff here? Well, the answer is no, you do not. Okay? If they give you two sides, 4 and 7, do I really have to do all this algebra? And the shortcut answer is really no. If you take a look at what I have here, how did we get to 8? Well, we took these two numbers here, and we just really subtracted them, guys. So to get that low end, all you have to do is subtract the two sides. Okay, how did we get this 38? Well, we took those two sides and we added them together. Okay, so a real quick way to do this is if they give you the two sides, okay, you're going to make your compound inequality here. To get the low end, you just have to subtract them. So 7 minus 4 is 3. Okay, and to get the large end or the top end, all you got to do is add them. So 4 plus 7 is 11. So there we go. We know that that third side has to be greater than 3, but less than 11.